Hi, welcome to another session of Circuits and Networks. In today's class 3 under GATE exam of transient analysis, we are going to see simple problems on transient analysis which were asked in previous GATE exams. So we'll start with the first problem. It was asked in GATE 2016 under set 1 for 2 marks that in a circuit shown, switch S2 has been closed for a long time. At t equal to 0, switch S1 is closed. At t equal to 0, S1 is closed, right? At t equal to 0 plus, the rate of change of current through inductor in ampere per second is, we need to find out the value for that. So this was asked for 2 marks and it wasn't a multiple choice question. So we need to get the value. So it's a simple problem. One need to concentrate on the property of the inductor. That inductor under long duration means for t equal to infinite, it will be being as short circuit. So we'll take first the initial conditions, that is t equal to 0 minus S1 is open, S2 is closed. So with this is how the circuit would be like. Now when S2 is closed, 3 volts will be supplying current of 3 by 2 amperes through this inductor, and that inductor would be shorted for long duration, and this was before closing of the switch. Now after the switch is closed at t equal to 0 plus, this is how the conditions of the circuit would be. S1 is closed and charged inductor will be having a current of 3 by 2 amperes which was flowing in this direction, and the voltage which will be developing across this open wire. Why it become open wire? Because S1 is closed, and as soon as S1 is closed, inductor will be being as open. So here you have the voltage across the inductor. For t greater than 0, you can show the inductor into the circuit, no problem. Anyhow, we need to calculate current, that is the rate of change of current at t equal to 0 plus. So we have to identify the node over here. So we have identified the node which is having a voltage of VL of 0 plus. Now applying KCL at this node, and I'll be framing the node equation at this particular node. So it would be VL of 0 plus minus 3 by 1. This is the one branch current. Outgoing current is 3 by 2 amperes plus VL minus 3 by 2 is equal to 0. This becomes the actual node equation for t greater than 0. Now taking the like terms of VL of 0 plus on one side and the constants on other side, we'll be getting the value of VL of 0 plus is equal to 2 volts. Now what is this voltage? It's the inductor voltage, and we know that the inductor voltage would be given as LdI by dt. So it is switch is placed at 0 plus, so I of 0 plus by dt is equal to 2. Inductor value from the problem, it is 1 Henry. So I'll get the value of di by dt, which is equal to 2 amperes per second. That is the rate of change of current. So this was asked for GATE for 2 marks under GATE 2016 for set 1 paper. On the next simple problem, which was asked in GATE 2002 for 1 mark, a current impulse phi delta phi del of t is forced through a capacitor C. The voltage Vc of t across the capacitor is given by the options you can see here: A, B, C, and D. Phi t, B option is phi u of t minus C, phi by C t, and phi u of t by C. Let me tell you, impulse function, it is given by del operator, and u of t represents the unit step function. So that you need to know from the basics of circuits and networks, as well as some basics with the mathematics. Now from the given data, I of t is nothing but phi del of t, that is the impulse current function. It is shown here, and we should know that the impulse function is given by del of t is equal to d by dt of u of t. Okay, now u of t, as I told you, is the unit step. So I'll be having the formula for voltage across capacitor is equal to 1 by C integral I of t dt. This is the basic formula of voltage developed across the capacitor. Now that value we are going to take into the consideration, that is I of t, which is phi del of t dt. And we know that this del of t is nothing but the impulse function, and integration of impulse, okay, we can change it to u of t. The integration of impulse function can be changed to u of t, and this phi goes out. This c remains as it is in the denominator. So phi u of t by c. Hence, Option D is the right answer. In the next problem, which was asked in GATE 2015 in set 2 for 1 mark, series RL circuit is excited at t equal to 0 by closing a switch as shown in the figure. Assuming 0 initial conditions, the value of d square I by dt square at t equal to 0 plus e is dash. So options here given values are A, B, C and D. You can see option C is 0, but that is not the right option. So we need to find out the answer. So before closing of the switch, that is I of 0 minus is equal to 0 amperes, because it's an open circuit, so current remains as 0. And as soon as the switch is closed, inductor doesn't allow the sudden change in current, so the value of I of 0 plus will also be 0 amperes. This will treat as equation 1. Now for t greater than 0, the above circuit will be changed to this circuit. That is, the switch is closed and voltage will be driving the current I of t through RL circuit. Now applying KVL to this closed loop, we get minus V plus R of I of t plus L di by dt is equal to 0. With this, Ri plus L di by dt is equal to V. This I'm treating as equation 2. At t equal to 0 plus, let me find out the value of di of 0 plus by dt. So we know that the I of 0 plus value is 0 ampere. So this R multiplied with 0 will go to 0, and L value will be remaining in the value as L only. So di of 0 plus by dt equal to V by L. Let us treat this equation as 3. Now after getting the equations 1, 2 and 3, we are interested to know what is d square I by dt square. For that, applying differentiation to equation 2. So you have this equation 2, and if at all you apply differentiation, you're going to get r di by dt plus L d square I by dt square. This v becomes the constant, so the differentiation of constant is 0. Hence, L d square I by dt square is equal to minus r di by dt. Now at t equal to 0 plus, this value d square I by dt square will be equivalent to minus r by L di by dt of 0 plus. From equation 3, its value is V by L. So I'll substitute the value, I'll get minus of R by L multiplied with V by L. In fact, this changes to minus RV by L square, which is option D. In the next problem, the capacitor initially has a charge of 10 coulombs. The current in the circuit 1 second after switch S is closed will be dash. So again, it was asked for 2 marks under GATE 2004. It's a simple circuit, RC circuit. Now RC circuit is excited by 100 volts when the switch is closed. So that is the conditions what we need to keep in our mind. And the options are given as A, B, C, Ds. So we need to check which option is the right answer. So after switch is closed for t greater than 0, this is how the circuit will look like. And it was given that the charge of the capacitor is 10 coulombs. So therefore, when current flows through the circuit, the voltage across the capacitor would be in this fashion. Now Vc of 0 plus has a formula of Q by C, that is the charge is given as 10 coulombs. That's why we have taken this equation. So Q value is 10, C value is 0.5. With that, I'll get the value of Vc of 0 plus as 20 volts. Now what would be the value of current? Current is nothing but the difference of these two voltages. That is the input voltage 100 volts and the capacitor voltage divided by this resistor. So 100 minus 20 by 2, it becomes 40 amperes. Now once I get the value of current, for t greater than 0, the current will be discharging, and its equation would be I of t equal to 40 e to the power of minus t by tau for RC network. Now what is this tau? Tau is nothing, the time constant of RC network, whose value is nothing but resistance is 2, capacitance is 0.5, the value of tau is 1. Thereby substituting this value in this equation, I will be getting I of t equal to 40 e to the power of minus t, and for 1 second, the value would be e power minus 1. So e power minus 1 value is 0.367 multiplied with 40 will give you the value as 14.71 amperes. So option A is the right answer. So these were the simple problems which were asked in previous GATE exam. So I have prepared this video for the simple problems. I hope you like this class. Please share among your friends, subscribe to this channel, and please press the bell icon for the future notifications. Thank you.